Good evening, dear students.
Good evening, ma'am.
Yes, good evening. Okay. So, so in the last class, we have completed, uh, okay, up to this particular question. Okay. So, today we are going to start with the 23rd question. So, we are discussing the MCQs on haloalkenes and haloarenes, right? So, let us continue. So first, few questions you have seen. So those were all based on alkanes, okay, based on haloalkanes. So now, so these are some of the questions based on arene, that is substituted aromatic ring, okay. So when the halogen atom is attached to a substituted your benzene ring, that is your aromatic ring, so they are called as what? Haloarenes. So let us start with this 23rd question. So the compound having longest CCl bond is, okay. So you might have, so we have discussed the nucleophilic addition reaction of haloarenes, okay. So we have discussed there the main important factors. We have discussed the main important factors which are what? Uh, uh, which are important for the nucleophilic reaction to take place, right? So which are the important points? Do you remember which are the important points which are involved for the nucleophilic substitution reaction? So which are the important points of which are the important factors, that is resonance effect, right? Then the difference in hybridization of CCX bond, remember? Then we see the instability of phenyl cation, right? So these are the important factors. Okay. So what they have asked that the compound having the longest CCl bond is, okay. So here are the four options: option A, option B, option C, and option D. Okay. So can you tell me, okay, Akila has answered as option number B. Dinesh has answered as option number A. Okay. Chetan has given C. Shri Varuni has also answered it as C. Babita has answered as C. 20. Okay. Babita has answered as C. C. Okay, fine. So let us see the answer now. So the correct answer is what it is? It is option number C. Okay, the answer is C. Why the answer is C here? Okay. So the in the first compound, okay, in the first compound, what you
Ma'am,
can
it is
see,
option C, na, ma'am.
what you can see in chloropenzene. Okay, so this is chloropenzene. This is
Ma'am,
chloropenzene. This is 1 chloro 4 nitrobenzene. Oh,
ma'am,
yes.
ma'am, it is option C,
One.
na, ma'am.
Yeah.
Longest CCl bond.
Yes, tell me, tell me.
Ma'am, that option C, na,
Option C only, no.
not ma'am, option D, na, ma'am. They have asked long CCl bond, na, ma'am.
Option D, which option D?
And
This one.
CH2 double bond CH.
Oh, no, no, option C. Option C is the answer. Okay, why it is option C, I will discuss. Okay.
Okay, ma'am.
Okay, so here, uh, can you hear it now? Is my voice proper?
Yes, ma'am.
Okay. Just a second. Fine. Okay, now I hope it is clear. Okay, fine. So let us continue. So I said what? So the compound having longest CCl bond. Okay, CCl bond among the four. Now, which are these four options? We'll see. So this is chlorobenzene. The first compound is chlorobenzene. Then the second one, B option is what? One, two, three. Okay, one, two, three. And at fourth position, what you have? Nitro. Then when you write the name, this is chloro and this is nitro. Okay, so we follow alphabetical order. So it will be 1 chloro, okay, 4 nitrobenzene. Okay, 1 chloro, 4 nitrobenzene. Then C option. Okay, what is C option? We have studied something called as allyl, right? Allyl compound. And here you can see this is what both are vinyl. Okay, allyl mean what? This is directly attached to the carbon CC double bond, right? Now here vinyl is what? This is a vinyl. Both are vinyl. You can say vinyl compounds. Here this is a vinyl chloride. So in vinyl chloride your halogen is attached to the carbon which is next to a carbon carbon double bond. You are also same. Okay, so this is attached to, so this is a vinyl chloride. So these are the four options. So what you can see here, that in chlorobenzene, okay, then in 1 chloro 4 nitrobenzene and your vinyl chloride. Okay, what is there? There is a double bond. Okay, here the double bond is not nearer. So you're in option A, option C, and option D. What you can see that there is a formation of double bond takes place. Okay, between what? Your CCl bond. Yes. So here also see, here is one carbon, here is one your halogen group. Here also, here is your carbon CCl bond. So in between all these three, what you can see, that is a double bond formation is taking place. Okay, but here you can see carbon is here and sorry, your carbon is here, double bond carbon is here and your halogen is here. So there is no double bond formation. Okay, so in other three options, what you can see that there is a formation of double bond is taking place between this CCl bond. Okay, and due to this, due to why the formation of double bond taking place? Due to resonance. We have studied, okay, in our ACE classes, what are the main factors for nucleophilic substitution reaction in haloarenes? Okay, first one is resonance. Okay, due to resonance, that is plus R effect. So because of the CCl bond, okay, in option A, option B, and option D, what is happening? There will be partial double bond formation taking place. Okay, and so because of this, the bond breaking of this bond will be difficult. Okay, so because of that, so it will be a strong bond. Okay, it will be a strong bond. So in other three options now. And this particular option C, okay, what is the compound name? So if I name the compound here, okay, if I start naming the compound, it is 1, 2, so 1, 1, 2, 3, and 4. Okay, so it is 4 chloro and it is a cyclohexene. Okay, why hexene? Because there is a one double bond is there. So it is 4 chloro cyclohexene. So in option A, option B, and option D, what you can see, there is a double bond formation between the CCl bond due to resonance. But in the compound C, okay, no resonance is taking place. Why? Why no resonance is taking place? Because the double bond is far. Okay, the double bond is far from the halogen group. Okay, you can see here the your carbon and your carbon. Okay, it is far from this double bond, your halogen and a double bond is very far. So because of that, no resonance is taking place. So if no resonance is taking place, okay, then there won't be any partial bond formation. If no partial bond formation, then the bond is not strong, okay, and it is a long bond. So CCl bond length, it will be longest in option number C. It will be longest in option number C. Understood? Is it clear? Is it clear? Is this question clear?
Then say the results once again, ma'am. Ma'am,
Yes, yes.
ma'am, say the results once again, ma'am.
Yeah. Okay. See here. Now here. So, so this compound. Okay. First compound, your carbon. This is your chlorobenzene. Okay, this is your chlorobenzene. So here what you can see in chlorobenzene, your CCl bond. Okay, so there is a CCl bond and there is a double bond formation is present. Okay, so because of the CCl bond, okay, so what, whenever there is a conjugated double bond system, whenever you have a double bond system, what will happen? It will undergo resonance, right? It will undergo resonance structure. Now, if I write the resonance structure, what do you mean by resonance? Yes, it will undergo what? Conjugation. Now here, if I write the resonance structures for your chlorobenzene. Okay, now here, just see. So this is our chlorobenzene. Okay, so electron donating group. So what it will do, the electrons of this chlorine, okay, it will involved in the bond formation. So what will happen? So because of this, okay, what will happen? There will be partial bond formation here. Okay, partial, now, do you know that when you have a single bond, CCl bond, when you have double bond and when you have triple bond, which is longest among these three? Which is the longest among these three? Which bond is longest? C single bond is longest, C double bond is longest, or C triple bond is longest? Anybody knows?
C single bond, ma'am.
Single
Yes,
bond.
C single bond is the longest bond. Okay. And this bond can be broken easily. Whenever you hold one single stick in your hand and you try to break, it will break. Okay. Now, similarly, when you see double bond, okay, when you see double bond, means what? Two sticks are present. Okay, now two sticks are present. Try to break the bond. What will happen? It is little difficult. So as, okay, as there is a two bonds, the distance, okay, the distance will be less. Okay, it will be slightly less as compared to the single bond. So this will be little, what you can say, not that longest. It will be little shorter. Okay, and triple bond. Okay, triple bond means what? Three sticks are present. Now try to break the bond. Again, it is more difficult. Okay, so this is the shortest. Okay, so now when we are comparing this first, third, and the first A, B, and D, okay, what you can see, due to the presence of the double bond, okay, it is undergoing what? It is undergoing partial double bond character. Okay, so because of that, what they have asked which is the longest bond. Okay, longest bond among this. So what we are interested in? We are interested in this combination. Okay, between the CCl bond. Okay, here also the CCl bond. Now here what you can see that everywhere, okay, wherever the carbon is present, there is a presence of what? There is a presence of double bond. Okay, so because of the presence of double bond, what it is undergoing? It will undergo resonance. Okay, it will undergo resonance and it will show partial bond formation, and the bond, okay, it will be what? It will be difficult. Okay, the bond breaking will be very difficult and it is a shortest bond. Okay, it will be shorter. Now here, when we see CCl bond, okay, now what you can say? It is a single bond. Okay, there is a single bond present. Is there any double bond present beside it? No. Okay, there is this carbon is not involved in any bond formation. So because of this, okay, in this option C is the right answer. Why? Because CCl bond here, okay, there is no double bond present, and because of that, it will not undergo resonance. That will not undergo resonance. So because of that, the CCl bond is longest. So remember this. Okay, whenever you have single bond, it is the longest bond. Whenever you have double, little shorter, and the shortest will be the triple bond. Okay, the bond distance will be very less. Okay, is it clear now? Okay, so just remember that in other three options, because of the presence of double bond, it will undergo resonance. Okay, and in option number C, there is no presence of double bond. Okay, here, beside this carbon, there is no double bond. So because of that, what is happening? It will not go resonance. Okay, and CCl bond here, it will be the longest. Is it clear now? Is it clear?
Yes, ma'am.
Okay, fine. Okay. So your option is option number C. Okay, answer is option number C. Let us go for the next one. Which of the following halide shows highest reactivity towards SN1 reaction? Okay, which is the which of the following halides? Okay, which will undergo. Okay, I have just again. So which of the following halides will undergo? Where it went? Huh. So which of the following halide shows highest reactivity towards SN1 reaction? So option A, okay, so this is ethyl chloride. Then you have butyl iodide, okay. Then you have your chlorobenzene, okay, and then you have benzyl chloride. So these are the four options. So can you tell which of the following halide will show highest reactivity towards SN1 reaction? Now we have discussed what is SN1 reaction. Okay, it is a nucleophilic substitution reaction, unimolecular nucleophilic substitution reaction, which follows two steps mechanism. Okay, with the formation of carbocation. Can you tell me which is the answer for this 24th question? You can. Okay, so your BB has answered as B, Shivarune has answered as D. Okay, others, anybody wants to try? HM, okay, has answered as B. Please update your names, okay? Fine. Next, okay, Lubna has answered as D. Fine. So I'll tell you the answer here. So which of the following halide, okay, they have asked will show the highest reactivity. So whenever we are seeing the rate of SN1 reaction, okay, whenever we are comparing the rate of SN1 reaction, the rate of SN1 reaction is directly, it depends on what we have seen, the rate of the reaction, SN1 reaction, rate of SN1 reaction, it depends on what? It depends upon the concentration of the substrate, right? Concentration of substrate. So here, it depends on what? It depends upon the this, okay? When we are seeing the SN1 mechanism, okay, it follows what? It involves the formation of carbocation. Okay, it involves what? Formation of carbocation. So more the carbocation stability, okay, then highest will be its reactivity. So rate of SN1 reaction is directly proportional to what? You can say to the stability of carbocation. Okay, to the stability of carbocation. Now, when we see methyl chloride, now we know that in SN1 reaction, tertiary carbocation is,
Answer is D, ma'am.
yes,
Answer is D, no, ma'am.
answer is,
D, ma'am.
yeah, yes, answer is D. Okay, I'll just explain it. Okay, so here tertiary carbocation, when we see the SN1, this reactivity, when we see the SN1 reactivity, so tertiary carbocations are what we have just discussed, that rate of SN1 reaction is directly proportional to stability of carbocation. Okay, so when we see the stability of carbocation, so tertiary carbocations are more stable, then secondary carbocation, then primary, and then is your methyl cation. Right. Now here, when we see the carbocation formation, okay, for the option number A, that is your ethyl chloride. So it will form what? CH3, CH2 plus. So this is a primary. Okay, so this is a primary this carbocation formation. Okay, and again option number B. So first step is what? First step we know. So I'm just writing the carbocation stability. So what it will be? So CH3. So this is also what carbon? So this is also a primary carbon. Okay, so this is also primary carbon. Then we have our chlorobenzene. Next we have what? Chlorobenzene. So when this benzene, okay, this CCl bond breaks, So what will happen? So there will be formation of a carbocation. Okay, so this carbon again, so this is a secondary carbon. Then when we see the next one, that is your benzyl cation, so CH2Cl. So this formation, okay. So again, so this is what here when we compare. So option number 1 and option number 2 are discarded. Okay. Now here, when we see option number C and option number D, what we can see that here, okay, when your chlorine, okay, when benzyl carbocation, so CH2Cl. Okay, so here you can see. Okay, so here when we compare your option number C and option number D, what you can see, this is a benzyl cation. Okay, benzyl cation is there. So it can easily undergo resonance formation. So when we compare option number C and option number D, okay, so benzylic carbocation is more stable, okay, among the rest options. Okay, so option number D is the correct answer. So this is a benzylic cation. This your positive charge, it can be resonance stabilized. Okay, when we compare the other factors, okay, so the reactivity, as we have stated that the rate of SN1 reaction is directly proportional to what? Stability of carbocation. And here when we see the stability of carbocation, we know that tertiary carbocations are more stable, then secondary, then primary, and methyl cation. So just now we have seen all the four options, and we have seen which is the carbocation. So in first and second, there are primary carbocations formation, and in C and D option, there is a secondary carbocation formation. But when we see D option, okay, the benzylic carbocation, it is the most stable. Why? Because there is a formation of benzylic carbocation, and this benzylic carbocation, it can be easily resonance stabilized. Okay, this positive charge can be easily resonance stabilized. So option number D is the correct answer. So who all have answered it as option number D? Option number D is the correct answer. Okay, so Akhila has answered, Shri Varuni has answered, Dubna has answered. Okay, so it is the correct answer. Fine. Let us go for the next one. 25th question. Okay, so in the reaction, so this is a reaction. So what is the reaction? This particular reaction is given, one compound is there. Okay, so this is joined with MgBr. Okay, so this is joined with MgBr. This is not separate. So MgBr plus CH3NH2 in the presence of dry ether. Okay, what is X? They have asked. What is X? So the number of possible isomers for the organic compound X is. So what? So first you find out the compound X, and then you tell how many possible isomers are possible for this compound X. So A, X, 5, then B, 3, C, 2, and D, 4. Okay, so can you tell the answer? What is the compound formed here? So when MgBr, okay, let me write the reaction here. So this is the reaction. So MgBr, when it reacts with our methyl amine, okay, in the presence of dry ether, in the presence of dry ether, what the compound will be what? So here, what will happen? So here your Mg, okay, so this bond breaks and it will forms what? It forms a isopropyl, okay, it forms a isopropyl plus your Mg, okay. So this Mg, it is MgBr, and this compound, that is CH3NH, NHCH3. So nitrogen, okay, so this will attack here. So it will be NHCH3. So the compound is what? Propyl, okay, isopropyl compound. So this is isopropyl. So what are the possible isomers? Can you tell me? Okay, this I will write. So it is CH3, CH3, and CH3. Okay. Can you tell me now? So this is isopropyl. Okay. This is a isopropyl. Can you tell me the possible isomers. Isomers means what? Isomers means the structural will be same. Okay, sorry. The number of carbons and the hydrogens will be same. Only the structural formula will be different. Okay, Dinesh has answered it as C. Chetan has answered it as Dinesh has answered it as D, and Chetan has answered it as C. Akhila
Ma'am,
has
B, ma'am.
Akhila has answered as B. Shivaruni has answered it as C. Okay, so the possible your this will be one will be, so this is your iso, like if this is 1, 2, and 3. So this is 2-methyl. Okay, 2-methyl propane. Another way of writing this can be your CH3, CH2, CH2, and CH3. So this is N-butane. So there are how many possible? Two isomers are possible. So option number C is the answer. Okay. So count the number of carbons and hydrogens in both the cases. So these are the two isomers. Okay. These are the two isomers, possible isomers for this particular organic compound X. Okay. Fine. Let us go for the next one. So whoever has answered it as option number C. Okay. Is the correct answer.
Option number C is answer, no, ma'am.
Yes.
Option C is answer, no, ma'am.
Yes. Option C is only the answer. Okay. So next question is prolonged exposure of chloroform in humans may cause damage to liver. It is due to formation of the following compound. So chloroform. Okay. So if you have visited your laboratories, if you have visited your labs, okay. So did you see chloroform in what type of bottle it is placed? It is placed in black color or brown color bottle. Okay. Very dark color bottle. Okay. In the dark color bottle, your chloroform is kept. Okay. Why it is kept? Okay, why it is kept in dark colored bottle? Because if it reacts with the sunlight, okay, so it may cause some harmful okay, it may cause some harmful reaction. So because of that, it is stored in a cool place and in a dark color bottle. So if a human being, okay, if he is exposed to chloroform for a longer time, okay, so it will damage its liver. Okay, it will damage its liver. So what is that reaction? What is chloroform converted into? Okay, so if the chloroform, okay, if it is reacted continuously with the air, okay, if it is continuously exposed to air and sunlight, so in the presence of air and your sunlight, what will happen? Chloroform is CHCl3. Okay, CHCl3. So what it will undergo? It will undergo slow oxidation. Okay, slowly it will react with the air, and what it will form? It will form highly poisonous gas. Okay, and which is the highly poisonous gas? It is a phosgene. Okay, it is phosgene. So there is an important reaction also, 2CHCl3. Okay, when it reacts with oxygen, that is in the presence of air, and if it undergoes slow exposure, okay, in the presence of sunlight, it will form 2COCl2 plus 2HCl. So phosgene, what is the formula? COCl2, option number A. Okay, option number A. Option number A is the answer. COCl2. Fine. So phosgene, remember this. So if a person, if he is continuously exposed to chloroform, okay, what will happen? Its liver will be damaged. Why? Because this chloroform, when it reacts with the air or and in the presence of sunlight, it is converted into a very poisonous gas. And that gas which is formed, it is a phosgene gas. Okay, it is for phosgene. Phosgene. That is COCl2. Okay. So I've written the reaction here. So 2CHCl3 in the presence of plus O2 in the presence of UV light, it forms COCl2 plus HCl. Okay. So this is the your this. Okay. Understood? Is it clear? So option number A. Answer is what? Option number A. Let us go for the next one. Okay, now there is one compound. Okay, there is one compound. You have to tell the IUPAC name. Okay, you have to tell the IUPAC name of this particular compound. So this is the compound. The correct IUPAC name of the compound is first one 4-ethyl 1-fluoro 2-nitrobenzene. Then B 1-ethyl 4-fluoro 3-nitrobenzene. C 3-ethyl 6-fluoro-nitrobenzene and D 5-ethyl 2-fluoro-nitrobenzene. Can you tell how you have to number? Okay, I'll give you the numbering. Okay, I'll give you the numbering. You name it. So fluoro, this is nitro group, and this is one ethyl group. Okay, so I'll start numbering from here. I'll start numbering from here. Okay, can you give the name now? Can you give the name? Akhila has answered it as A. Others? I've started the numbering from fluorine. Aishwarya has answered it as A. Okay, everybody has answered it as A only. So when we have the numbering system, okay, we have to follow what? Alphabetical order. So at first, okay, we have fluoro group, we have nitro group, we have ethyl group. So what will come first? Ethyl will come. So it will be what? It will be 4 ethyl. Okay, 4 ethyl. Then we have after E, F will come. So it will be 1 fluoro. Okay. Then at 2 position, we have nitrobenzene. So option number A is the correct answer. Yes. So maximum students, everybody has answered it as option number A. Very good. Okay. Fine. So IUPAC naming is very important. Okay. Let us go for the next one. So this is a reaction. Okay. So this is a reaction, one compound when it reacts with Br2 in the presence of UV light. Okay. So this is a compound when it reacts with the Br2 in the presence of UV light, it gives you A. Okay. So you have to tell which is the compound A. So these are the four options. So these are the four options. So I'll just minimize this a bit so that four options will be covered. Okay, fine. So these are the four options. Can you tell me the answer?
And once again, question, ma'am.
Question is displayed there. So this is a when we know that when we have any halogen, okay, when we have halogen in the presence of light, okay, or in the presence of sunlight, or in the presence of heat, okay, or H nu, that is your UV light, it will undergo what? It will undergo free radical mechanism. Okay, it will undergo free radical reaction. So we have a free radical reaction. So just see the free radical, which is the free radical reaction it will undergo. Okay. Chetan has answered as A, Raj has answered it as A, Sri Varuni has answered it as B. Okay, I'll just see the options, all the four options. Okay, so these are the four options. Lubna has answered it as A. So here, what it will undergo? So, okay. Now, free radical means what? The breaking of bond takes place evenly. Okay. Now here, there are two possibilities. Okay. Either the Br2 will attack at, so I'll write the compound here. So this is a nitro. Okay. Nitro substituted. Okay, so in the presence of a halogen, that is Br2 in the presence of UV light. So there are two possibilities. Okay, there are two possibilities. Either it will break the here, it will attack here, or it will attack here. Now, if it attacks here, okay, what will happen here in this? Okay, so here stability. Okay, if we see stability, so this will be a primary carbocation and this will be secondary carbocation. So preferably it will attack at secondary carbon. So what will happen? One of this hydrogen. Okay, so what will happen? Let me write. So rest all compound will be same. So rest all compound will be same. So it will be NO2 and here it will be CH, Br and CH3. So at one of the hydrogen will be replaced by your this, okay, your Br group. So this is your free radical substitution take place, okay, at the alkane part. So this is a benzyl free radical. So this is a benzyl group. So benzyl free radical is more stable because it is a secondary carbon. Okay, it is a secondary carbon. And this benzyl group, we have just now seen in the previous option also, benzyl carbocations are more stable because this positive charge can be easily resonance stabilized because next to this only there is a presence of what? Your benzene ring. So because of that, benzylic carbocation. So option number B is the answer. Okay, option number B. Okay, so whoever have answered it as option number B, yes, option number B is the correct answer. Why? Because benzylic carbocations are more stable. Okay, benzylic carbocations are more stable. Why benzylic carbocations are more stable? Okay, because this positive charge, it can be easily resonance stabilized. Okay, because next to this benzyl group only there is a benzene. Okay, so aromatic ring is there, so it can be easily stabilized. So option number B is the correct answer. Let us go for the next one. The order of reactivity of the compound. Okay, so there are four compounds in SN2 reaction E. So can you tell the order of reactivity? So let me write the compounds. So these are the four compounds. Okay, so these are the four compounds. You have to tell the order of reactivity. So first one is uh, C6H6, C6H5, CH2Br. Okay. Then another is C6H5, CH. Then you have C6 and Br. Okay. This is another compound. Then you have C6H5, CH, CH3, Br. Then another is, I'll write little down. Okay. Another is C6H5, C, CH3, then again C6H5 and Br. Yes. Can you tell the reactivity in SN2? Okay. When we see the SN2 mechanism, we have to remember that methyl carbocations are more stable, then primary, then secondary, and then tertiary. Remember this and write the order of reactivity of this compound. So which will be more stable? Yes. Now when option number just now, okay, I'll take another color here. Now here. Now here when we break the compound, okay. So you have to tell the order of reactivity. Now this one, okay. Now we know that primary are more stable. Okay. Now here when we break this bond, so here one carbocation is formed. So this is what? This is a your primary carbocation is formed. Now here this bond is formed, so this will be a secondary. Now here when this is broken, so again this is also a secondary. Okay. Now here when this is bond is broken, so this is a tertiary. So this is what first, okay, when we write the order of reactivity, we'll write from highest to lowest. Okay, we'll write from highest to lowest. So your they are given highest from lowest only. So this option number which will come first. So this, okay, because this is sterically hindrance. Okay, you can see there are larger groups. There are larger groups. So this is least stable. Okay, this is the least stable. So this is first one. Option number, this will come first. Okay, this is the least stable. Then second is what? Second is this one. Okay, second one is this because there are two big aromatic rings. So second one is this one. Okay, so this is the second least stable. So first one is this, then will be a second. Then next is what? These are the again two bulkier groups. So this will be third and this is the most stable. Okay, so option number, this will come. So just see which is the answer. I'll show you the options now. You see. Okay, so why I have told you why it is least stable option, this one, because the steric hindrance is there. Okay, we are seeing the steric hindrance. So can you see? So these are the all options. Option number B, your option number C. Okay, and this is option number D. So first one, it will be this compound. Okay, let us see this C6H6. So where it is first one, your okay, here it is first one. Then second one is okay. Then third one is 1 and 2, correct? So option number A is only the correct answer. Okay, option number A. Understood? Here other options also we will see. No. Okay, so this is the most stable. This is the most stable. So option number B is wrong. Then option number C. Option number C we will see. Option number C. No, this is wrong. Okay, because here one phenyl group and one methyl group is there, but our two phenyl groups. Okay, so that is the least stable. So option number again C is also wrong. Option number D. Option number D. 1, 2. Okay, but there is methyl group also here, but there is no methyl group. So this is also wrong. So option number A is the correct answer. Okay, option number E is the correct answer. Is it clear? So whenever we are seeing the reactivity, remember the stability. Okay, remember the stability. So whenever they have asked for SN1, SN1 means what is stable? Tertiary carbocations are more stable, then secondary, then primary, and then methyl carbocation. This is in case of SN1 mechanism. When we see SN2, then we have to see that methyl carbocations are more stable, then primary, then secondary, and then tertiary. Okay, why we are not taking tertiary carbocations? Because steric hindrance is present. What do you mean by steric hindrance? Steric hindrance means what? Steric hindrance means if there are presence of bulkier group, okay, if big groups are there, we know that in SN2 reaction, nucleophile will attack from behind, okay. So if there are big groups, okay, if phenyl groups, 3 phenyl groups are there, what will happen? The attack will be discarded, okay. Attack is not possible. So because the attack is not possible, we are interested in SN2, we are interested in methyl carbocations, then primary carbocations, okay. So methyl carbocations and primary carbocations are the most stable and tertiary carbocations are the least stable. Again, there is, now here we had seen there are 3 secondary carbocations. Okay, tertiary carbocation 1 was present. Then 2 secondary. Then we have to see which are the more bulkier group. Methyl group is more bulkier, or phenyl groups are more bulkier. Phenyl groups are more bulkier than the methyl groups, right? So like that we have to compare. Okay, so this is our this. Okay, let us go for the next one. Okay, next question. Okay, the major product of the following reaction is, so this is a reaction. You have to tell which is the major product. Okay, so CH, 30th question. 30th question. So this is CH3. Okay, so this is CH3, CHBr, CH2Br. Then this is CH2, double bond CH, CH2Br, and this is CH3, CHBr, CH2OH, and CH3, CHOH, CH2OH. So what is undergoing? Now we have studied something called as Markovnikov's rule, right? Do you remember Markovnikov rule? So this is on behalf of Markovnikov rule. In Markovnikov rule, what they've what is Markovnikov rule? According to Markovnikov rule, now there is a this alkyl halide is there. Okay, here you have what? Hydrogen bromide is there. Okay, your hydrogen bromide. So what will happen now? you can see there is an unsymmetrical alkene. Now we have discussed what is unsymmetrical alkene. Okay, symmetrical means what? Now when we, that is, your double bond is in between the two similar atoms, right? So this means on either side of the double bonds, number of atoms are same. Okay, so then it is called as symmetrical. Unsymmetrical means what? Unsymmetrical means what? Now, when we see a double bond, on either side of the double bond, the number of carbon atoms are not similar. So that time, how the addition will take place? So that time we are going to follow what? We are going to follow this Markovnikov's rule. Okay, Markovnikov's rule. So according to Markovnikov rule, what will happen? The negative part will be added to the carbon with least number of hydrogens, right? Remember that? Yes, okay. So tell me the answer now. So many have already answered. Chetan have answered it as B. Sri Varuni has answered it as A. Dinesh has answered it as B. Kencha has answered it as A. Akhila has answered it as A. Okay. Others? Fine. So the answer, so this was a question asked in 2021. Okay. So your Markovnikov rule is also very important. So when we let us write now. So when we write the reaction, okay, so what will happen? So either side of the carbon, okay. Now here, what will be the possibility? So here your negative will be added to the carbon with least number of hydrogen atoms, okay. And your hydrogen will be added to the carbon with more number of hydrogen atoms. So it will become CH3, CH, Br, okay, CH2, OH. Fine. Now here, so our answer is what? Our answer is again, so again HBr. Okay, excess. They have taken excess of HBr. Okay, they have taken excess of HBr. This. Now what we are going to do next? Again, we are going to react it with HBr. Okay. Again, we are reacting with HBr. So what will happen? Your OH group will be replaced by Br group. So it will be CH3, CHBr, CH2, Br. So which is the answer? So this is CH3. Okay. So it is CH3, CHBr, CH2Br. Yes, option number A is the answer. Option number A is the answer. Okay, option number A is the answer. Understood? Okay, so what we are doing here? We are following Markovnikov rule. Okay, we have taken excess. So what is happening? There is a OH group. So OH group is just replaced by PR group. So option number A is the correct answer. So CH3, CHBr. Okay, so yes, CH2Br. So option number A. Fine. Let us go for the next one. In the following pairs of halogen compound, which compound undergo faster SN1 reaction? Okay, now they have given you compounds, okay, and you have to tell which will undergo faster reaction. So these are the compounds 1 and 2. Okay, so tell me among this which will undergo faster reaction. I'll just zoom it, okay. So these are the 4 set of this. Okay, you tell me. Okay, so these are the 4 set. Okay, so here. Okay, so here you can see in the following pairs of halogen compound, which compound will undergo faster SN1 reaction? Yes, which will undergo faster SN1 reaction? So 1 and this one, okay, and this is second one. So among this, okay, 4 which will undergo faster. Which pair they have asked? Which pair? When we are undergoing SN1 reaction, we have to see for tertiary carbocation stability. Okay. Now here, when we see the tertiary carbocation stability, let us write the carbocation formation for all. Okay. So if this bond is broken, so what will happen here? Here the CCl bond. Okay. So if this is broken, so carbocation formation. So this is what? your secondary, your tertiary carbocation. So this is tertiary carbocation formation. Then second option, okay, so second option, if this is broken, so what will happen here? So this is again a secondary carbocation. Okay, so this is less stable as compared to the first one. Then when we go for the next one, this one will write, so Cl, okay. So when it undergoes, so this is what? This is again a secondary carbocation because this again is attached to two carbons. Okay, so it is a secondary carbocation. And the fourth one. So if this is broken, then what will happen? So this here the carbocation formation takes place. So here it will be. So this is a primary carbocation. So this is the least stable. So which is more stable? We have to see. So first one answer is which is the first pair? This one. Okay, this is the first pair. Then second one is what? Here, when we compare your, these are the, this is also secondary carbocation, this is also secondary carbocation. But when we compare this and this option, okay, this is the most stable. Okay, this is the most stable. Okay, so higher the stability of the carbocation, higher will be the rate of the reaction. So option number, so let us see the options now. Let us see the options. Okay, so these are the options. Okay, so you can see the options. So our option is first one. Okay, in the A, in the first one we have 1, and in second one this one. So we have 1 and 2. So option number A is no, B is no. This is least stable. Okay, this is primary carbocation formation. This is also no. Option number C is also no. Okay, then option number D. Let us go for option number D. Yes, option number D is our correct answer. So option number D. Okay, option number D. So this is our tertiary carbocation and this is our secondary carbocation. So option number D is the correct answer. Yes, Sri Varuni and Lubna have answered it correct. So option number D is the correct answer. I hope you have got it. Okay, so like this, you have to see the stabilities. Okay, fine. Next one, which of the following chlorohydrocarbon readily undergoes solvolysis? Okay, so here we have seen this. Okay, so here the answer is what? It is option number A, because benzyl carbocation. Okay, benzyl carbocations are more stable. Okay, due to resonance. So option number A is the answer. So we know. So whenever any benzyl carbocations are there, benzyl carbocations will be the most stable. So it will easily undergo solvolysis. So remember that. So option number A. Let us go for the last question. I hope 33rd question. Yes, last question. Identify the products A and B in the reaction. So these are the two reaction. Okay. RX reacts with AgCN, gives you A plus AgX. And second one is RX reacts with KCN, gives you B plus KX. What is A and B? What is A and B? When it reacts with AgCN, what it forms? What it forms with AgCN? Okay, AgCN is what? It is a covalent. Okay, it is mainly covalent type of bond is formed. So it will form NC. Okay, it forms isocyanides. Okay, so AgCN is covalent, and we know that nitrogen is a free. Okay, it is free to donate the electron pair to the carbon. So this forms isocyanates. And what type of bond is formed? Covalent bond is formed. Okay, because the nitrogen can easily donate the pair of electron, and KCN is a ionic bond. Okay, KCN is ionic, and it can easily dissociate into K plus and Cn minus. Okay, so that time what will happen? Our cyanide will go and attack. So it forms cyanide group, RCN. Okay, so A is our isocyanide and B is our cyanides. Okay, remember that. So AgCN, it forms covalent bond and it forms isocyanides, and KCN, it forms ionic bond and it forms cyanide. So option number A. Yes, option number A is the correct answer. Is it clear? So These were some of the MCQs. So for this chapter, we have solved some 33 questions. Okay. From haloalkanes and haloarenes. So if you get some more questions, you can solve. So by this, I have completed the chapter haloalkanes and haloarenes. So in the next class, I'm going to start with the new topic. Okay. New chapter I'm going to take, and from that chapter, we are going to solve the MCQs. Okay. So try to solve such questions, more questions on this particular chapter. Okay. From different books. So it will help you. Okay. Fine. So any doubts? Yes.
No, ma'am.
Okay. Fine. So by this, I shall end the session here. Okay. We'll meet in the next class. Thank you.